Namaste and a very good morning to all our uh, participants, panelists, and of course a very warm welcome and namaste to our resource person for the day, Professor Amba Kulkarni Didi. Uh, Ambaji has already joined us and a very warm welcome to you. Of course, we are blessed to have you and our students are going to be enlightened by your presence and by your session. Moreover, I wish to make a small announcement for the participants. There'll be a parallel session running on the Sanskrit communication studies that were going on. And all the participants who would like to join the Sanskrit communication session may join the other link provided in your mail, wherein it's a Hindi session with a Hindi session written on it. May join in that link. But right now, for this particular session, we have a linguistic session where our resource person, Professor Amba Kulkarni, is already with us, and she'll be talking to us a lot about linguistics, a lot about the linguistic aspects of Sanskrit, and we'll begin our session at 9:30 sharp. Till then, if any of our participants would like to communicate, would like to share something, would like to talk about the same. Yes, good morning, Saurabh. Good morning, Beta.
Yes, ma'am. Good morning.
Good morning, Saurabh. How have these 2 days been and how was the Deepavali celebration?
Good, ma'am.
Good. So you had the morning yoga class?
Yes, ma'am.
Very nice. So you just watched it or you did the exercises also?
Okay.
Would you like to share something, Saurabh?
Yes, yes.
Please go ahead.
Okay, ma'am.
Would you like to share something, Saurabh?
No.
Okay. Okay, beta. Then we have, yes.
What, ma'am?
Yes, Polam ready. Your mic is also unmuted. Would you like to share something? Yes. Sanjay?
No, ma'am. No, ma'am. I am not Halki.
Okay. Okay. Manjeet Kumar? Good morning. Namaste.
Good morning, ma'am. Good morning, ma'am.
Yes. And Manjeet, would you like to share something or know
No,
something?
ma'am.
All right. You attended the morning class, the yoga class?
Yes, ma'am.
Okay.
Yes, ma'am.
That's good. That's good. So you're waiting for the next session to start?
Okay, ma'am.
Yes.
Hello.
Namaste, Professor Kulkarni. welcome to the session.
Yeah, thank you very much. Nice to see you all.
We are blessed to have you with us, and our session will start sharp at 9:30.
Sure.
We are just waiting some of the students to join in.
Yeah, no problem.
Yes.
Good morning. Now class. Yeah.
Turn mobile.
Yes. Good morning, Satyaji.
Good morning, ma'am. Ma'am,
Yes,
can you please enable the chat section?
we'll try to do that. Okay. I'll
Yes,
just
ma'am.
communicate the same to the technical team. Okay.
Yes, ma'am. Okay, ma'am.
Okay. Yes, Varshini.
Ma'am, every day we used to have a SAR, no ma'am?
Yes, every day we used to have what, beta?
Every day we used to have Sachin sir taking for us.
Yes, Sachin sir is also there. You've received the Hindi link also?
No ma'am, I'll
The
listen in
link
English.
mentioning Hindi?
Yes ma'am, I saw them ma'am.
You saw that?
Yes ma'am.
Okay. So there are two parallel sessions running. Today we have Professor Amma Kulkarni ma'am with us. She's also going to talk to us about linguistics.
Yes ma'am,
Okay.
thank you
And
ma'am.
there's yes. Good morning, Priyanka. Namaste, Priyanka. Priyanka, there's some problem with your mic, beta. It's giving a bit of a trouble. We're not able to hear you, beta. You can just mute your mic because it is giving a lot of background sound. Good morning, Rishikesh. Namaste.
Namaste, ma'am.
So, how was the morning session?
It was really nice with Saurabh Botra ji, ma'am.
Yes.
And what happened to Rajesh ji?
I think he's not feeling well, probably.
Oh, okay. Wishing
Yes.
him a speedy recovery.
Definitely, we all are wishing him a speedy recovery.
Yes.
Yes. So, we'll begin the session now. I think.
So, madam, just I wanted to know, all
Yes.
these are the new students who have joined, right?
Yes, they are going to be, yes, they are the new entrants into BTech first year.
Ha.
And it is the induction program.
Ha.
And it's a AICT has taken this initiative
Yeah.
to have a module or a sampler induction program.
Right.
And the students have been very actively participating in the same.
Good.
So, yes, since it is already 9:31,
Yeah.
so I think we should go ahead
Sure.
introducing you to the children so that we
Sure.
can.
Sure. And these students, they know both Hindi as well as English. They are from North Belt.
They are from all across.
Okay. Okay, fine, no problem.
They
So,
are from all across, and they will. Some of them are not very comfortable with the
Hindi.
Hindi.
Okay, no problem. I will speak in English. That's not an issue. Okay.
They are not very. Some of them are not very comfortable with Hindi, and the students who are from the North Belt, they are comfortable with it.
But they are comfortable with English, all of them, right?
Oh yes, all of them are very
Sure,
comfortable with it.
sure. So I will speak in English, no problem.
Yes.
Good.
So let me just take this opportunity to, of course, extend a very warm welcome and introduce ma'am to all our participants.
Sure.
So though the children are joining in, yet I'll take this opportunity to introduce ma'am. Professor Amba Kulkarni is the head of Department of Sanskrit Studies at the University of Hyderabad. Madam is MSc from Shivaji University, Kolhapur, MTech in Computer Science from IIT Kanpur, PhD in Applied Linguistics from University of Hyderabad, and MA in Sanskrit from KSOU, Mysore. Of course, ma'am's focus of research on Indian grammatical theories for computational processing of Sanskrit text. Ma'am has been awarded Vishisht Sanskrit Seva Vriti Samman in 2015 by Rashtriya Sanskrit Sansthan, New Delhi, for her contribution to the studies and research on Sanskrit-based knowledge system. Madam has authored a book on Sanskrit, passing based on the theories of Shabdabodh. With these words, of course, a very warm welcome to Professor Amba Kulkarni ma'am, and I'm sure the students and the participants will be waiting to listen to you and they'll be enlightened by your talk. So over to you, ma'am.
Yeah. Can I share my screen?
Yes.
Yeah.
Dian Pandebhaiya? Yes.
Can you see this?
Yes.
Yes.
Yes. Good.
Screen is
Great.
looking.
Great. Good. Thank you very much for inviting me to this talk. I will be talking on Panini, the foremost programmer. Well, few participants have raised hands. So are they interested in asking questions before I start?
Probably yes.
Sure. So please,
Divya?
that
Yes.
that will be good. So
Yes. If any of the students would like to ask ma'am, yes, Divya, would you like to ask ma'am something?
No, ma'am, it's okay.
Okay.
No, because there was a hand raised, so I thought.
Yes, definitely.
Okay.
Shreya, would you like to ask ma'am something?
No, ma'am.
Okay. Okay.
Okay. Fine. So you can see my screen, right?
Yes,
Okay.
we can see it.
Okay. So today I am going to talk on Panini, the foremost programmer. Okay. So all of us may get surprised because we do not know who is Panini, and programming is the something which emerged only few years back. The word program, computer program, as all of us know. Well, so first let me tell you who Panini is. Panini is a first grammarian, or I should say the first formal system of grammar for Sanskrit was written by Panini in the form of Ashtadhyayi. So Panini was around 2500 BCE, 2500 years old ago. Panini was there. He was a Muni, or we can call him Rishi. Muni, by Muni we mean somebody who does the mananam, manana chintana, contemplation. Somebody who does the contemplation is called Muni in Sanskrit. And Rishi, somebody who can see beyond something. So essentially, these were the great thinkers from India, Muni and Rishi. They were the great thinkers from India, and Panini was one of them. What Panini did was he wrote a grammar for Sanskrit. And this grammar for Sanskrit is something like a computer program. So I thought I should introduce all of you to this, because all of you are going to be engineers, and definitely you were introduced to computer programming or will be doing computer programming as computer science graduates. So naturally you should know who is the foremost programmer, right? Uh, of course, you might have heard the name of Euclid, who gave the algorithm for finding the GCD, okay, the greatest common divisor. So this algorithm, which Euclid gave, similar kinds of algorithm Panini also gave. And Panini and Euclid were almost contemporaries. So both of them, they existed around 2,500 years ago. Euclid was there in Europe and Panini was there in India. So what Panini did and what is this grammar about? Uh, Many of you might have also heard that Sanskrit is the best language for computer and all that. So actually, it's not Sanskrit language as such which is best for computer programming, but the grammar which Panini wrote and all the theoretical developments that took place after Panini wrote this grammar, all these are very much useful from programming point of view or from knowledge representation point of view. Knowledge representation, you might have heard the term, which is there in artificial intelligence. How do you represent the knowledge? So whatever we hear, whatever we see, we get knowledge from it. How do we represent it so that we can process it automatically? This is the basic fundamental aim of any knowledge representation system. So what is meant by processing? We should be able to infer something from it. We should be able to add some knowledge to the existing knowledge without disturbing the structure. The structure should be such that it is computable and all that. So this knowledge representation scheme which Indians have given is something which is very useful, and that's why they say Sanskrit is the most suitable language for programming, etc. So I am going to give you some hints from what Panini did some 2,500 years back. Okay, so as I told you, Panini was Panini existed around 2,500 years ago, during 500 BCE, and he wrote the grammar for Sanskrit language. And this grammar is such that it is almost complete and it is still available to us. Still available means what? Continuously for 2,500 years, this grammar is being taught from a teacher to a student, and there is no gap in it. So still, even now, we have several grammarians who are teaching grammar the way Panini and his um, shishyas, his students, taught to their students. The same way this Panini's grammar is being taught even now. So it is something like a living museum, you can say. Now, this another here I would like to tell you one thing. Such a grammar does not exist for any other language in the world. Let me say, even if you take English, for English, just recently people have developed computational grammars, but a computational grammar for Sanskrit existed 2,500 years ago. And this grammar is written in the form of sutras. Now, what is a sutra? Sutra, they have defined sutra as alpaksharam asandigdham saravat vishvatomukham astobham anavadyam cha sutra vido viduhu. So sutra is defined as, now see these terms, though they are from Sanskrit, you may not find them very difficult. Alpaksharam, alpa aksharam, alpa means those who are from Kannada, they know swalpa. Swalpa is very little. Alpa is very little. Aksharam, Akshara. So it has very less number of aksharas. Okay. Then asandigdham. There is no ambiguity. It is unambiguous. सारवत, सार, you know, सार हिंदी में हम कहते हैं सार निचोड़ना. And then rasam is also called saram. So this sara is the extract. So this saravat, like dhanavat, shilavat, shuravan, we say. So saravat is something which contains the essence. Okay. And then vishvato mukham, vishva is whole complete universe is there in it. That means it is general one. In the Vishvato Mukha means it is general. Astobham, it is continuous. There are no discontinuities. It's not that one part of sutra is at one place, another part is at another place. It's continuous. And anavadyam, it is without any flaw. That means there are no words which are meaningless or something like that. And then there is no defect in it. So, see, this is something like a mathematical formula. Even mathematical formulae are like this. They are very crisp, very small. Like when you define a circle, you say x square plus y square equal to r square. A very concise formula. Then there is no ambiguity in it. Then it is something which gives you essential property of a circle. It is general one. It's not that only for small circles this is the formula. Whatever is the radius, same formula holds good. And then it does not have any flaw in it. When the definition is given, it does not have any flaw. So these sutras which Panini gave are like formulae. Okay. So and then there were around 4,000 sutras. These 4,000 sutras are divided into 8 chapters. Each chapter has 4 sections. So this is and since it has 8 chapters, it is called Ashta Adhyaya. Ashta, 8, and Adhyaya is chapter. So Ashta Adhyayi is the one which has 8 chapters. So that's why Panini's grammar is called Ashtadhyayi. Now, I am going to tell you about some innovative data structure which Panini used in this Ashtadhyayi. Now, you will say, what is this? How can there be data structure in those days? This is the beauty. So, I am going to tell you how innovatively he has, how innovative he was in designing the data structure so that he can represent the information, whatever he wants, in precise way. Hello? Yeah. So if you have any questions, you can stop me and ask, okay? Okay. So are there any questions so far? No? Shall I go ahead? Yes.
Yes. Shreya, would you like to know something, beta?
No, ma'am, no problem.
Okay. Okay.
Okay. Okay, fine.
There are
So,
plenty of more children, maybe Dr. Vikas. So would you like to know something?
okay. So
Okay, ma'am. We can
yeah,
continue.
and madam, if there are any questions, please stop me. Don't
Yes, yes.
okay.
Yes.
And
Yes.
I will explain. Okay,
Yes.
because this is something where I want students to understand the things. It's not that I just go on speaking and then with online classes there is this problem that we don't
Ma'am?
see the faces. Yeah.
Yes.
Yeah.
Ma'am, can you please tell the origin of the Maheshwara Sutrani, ma'am? Like, how did
Yes.
Panini derive
Yes,
I om
I'm
Grok A
yes,
om I
yes, yes.
also
Good,
so
good.
on?
I'm coming to that only. Okay.
Okay.
I'm coming to that. Okay.
Thank you, ma'am.
So yeah. So this is the topic which I'm going to address now: Shiva Sutras or the Maheshwara Sutras. These are also called Maheshwara Sutras. Maheshwara is the name of the Shiva. So either Shiva Sutras or Maheshwara Sutras. Okay. So all of us are familiar with this normal arrangement of the alphabet. Ka kha ga gha nga, cha cha ja jhanya, ta tha da dhana, ta tha da dhana, pa pha ba bha ma, and yara lava shasha saha. Okay. Uh, and you will see that this 5 by 5 matrix is very interesting, ka kha ga gha nga, etc. And here kacha ta ta pa. So there are 5 rows and 5 columns. What does the row indicate? A row indicates what is the position or the place of origin of these sounds in your mouth cavity. So ka kha ga gha nga, these are kanthya. Then cha cha ja jhana, these are the talavyam. Then you have murdhanya ta tha da dhana, ta tha da dhana, these are dental, dantya, and papha babhama, these are the austhya. If you see how where the tongue touches, you will notice that tongue touches various parts of the uh, mouth cavity when these sounds are pronounced. Similarly, the columns have different properties. Now, I'm not going to going in detail with these, because these we will be looking at tomorrow again in detail. So I'm not going in details with what each column stands for. Okay, so already this very scientific arrangement was there, but then Panini had some requirement. And what was his requirement? He wanted 41 subsets of this alphabet to describe various operations. Now, what Panini was doing was, he was trying to define rules, uh, give rules for various kinds of operations in on a language string. So, for example, Sandhi operation, like Rama plus Alaya or Vidya plus Alaya becomes Vidyalaya. Rama plus Alaya becomes Ramalaya. So, and various other such Sandhi rules. So, he required, for these operations, he needed certain subsets of this alphabet. And what kind of subsets he needed? So these are some of these subsets. Sometimes he needed all vowels. Sometimes he needed all consonants. Sometimes he needed vowels and then ya, va, ra, la, which are called semi-vowels, and nasals, that is yama, na, 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 the fifth uh, column in that 5 by 5 matrix. Sometimes he needed bagadada, sometimes he needed bhagadada, etc. Or such a
Hello.
set. Yes, hello. Yeah. So he needed various kinds of these subsets. So just imagine this one. Suppose you are organizing some program in your college, say a social gathering you are organizing. Now, when you are organizing a social gathering, you need various committees. One committee who will take care of the guests, one committee who will take care of the arrangements of all the furniture or the chairs, etc. One committee who will look at the stage arrangement, another committee to chop out the program, somebody to do the anchoring. So you need various committees. Just imagine that there are 41 volunteers who are there to work with you, and you need 41 committees. Okay, and some committees will have 2 members, some will have 5 members, some will have 30 members, something like that, depending on the nature of the work. So imagine 41 committees and 41 volunteers, and the same 41 volunteers are there in one or more than one committees. It's not that different committees have different students. Okay, we have only 41 students. So what we will do is, as an organizer, suppose now I need to remember in which committee which student is there. What I will do is, I will create a 41 by 41 matrix, and then I will write down the committee names across the rows, and then across the columns I will write down the student names, and then I will tick mark which student is there in which committee, and so on. So 41 by 41, that means 1681 or 82, 1681 bytes we will require if we want to store this in computer. Okay, so this is a kind of data structure, the matrix, which we can visualize. But what Panini did was something very interesting. These were these were the sets. He found that these are partially ordered sets. So now what are these sets? Each committee is one set. Okay, so there are 41 sets, and these 41 sets he found that they are partially ordered. Now what is meant by partially ordered? Subset relation. A is subset of B, and suppose B is subset of C. So here we have one set, here is another set, and here is another set, and AN is subset of AK, which is subset of AC, which is subset of AT, and so on. This IC is subset of IK, IC is superset of IK, and AK is also superset of IK. So these are called partially ordered because this is not complete order. See, partial means here there is no order between AK and IC. Okay, so not that all sets are one set is subset of another is subset of third, and so on. It's not like a linear order, but you have a partial order where there are two sets which do not have any relation between them, but both of them are superset of something else, or both of them are subset of something else. So this is called a partially ordered relation. So this is a mathematical terminology in mathematics. These are called posets, partially ordered sets. So we have these posets. And what Panini did was something very interesting. He said, I am going to write these posets as a linear list. See, if you have something like this, you can write linearly. Or if you have the last row, this line, you can write linearly. But each one of them is linear. But when all of them are together, you have all sorts of these crossings, etc. Now, how to make it linear? This is the question. So it is something like you have this kind of garland, and you want to make this garland linear one. Okay, where these knots or flowers are there, various flowers with various colors. Now what Panini did was very interesting. He arranged them linearly like this. So these blue ones are Ivu, Rurlu, etc. These are the 41 varnas, okay, or 41 volunteers in our case, okay. And he added some markers here, okay. So it is something like, suppose you have a garland, a mala, with all these A, E, U, Rurlu, etc. as the flowers. In between there are knots. Na, Ka, Nya, Cha, Tha, all these are the knots in between. So he created such a garland. So now how to get those committee names, etc., I will tell you. But now with this representation, what he did was these 41 were there, plus he added these 14 markers, the ones which are there in red color. So 41 plus 14, they become 55. Or I think it is 42. 42 plus 14 becomes 56. So now you need only 56 bytes to store this structure, which we were thinking of storing as a matrix. He has stored it as a linear list, and the memory that is required for matrix, we needed 1600 bytes minimum, okay, 1600 and odd. And here he could represent it with just 56 bytes. See how much compression he achieved. Now let us try to understand what is this data structure and how he arrived at it. So first let me tell you about the data structure. See, what we wanted was what is the name of each row, and in each row which elements are there, which students are there in which committee. Rows are the committee names. Now what he did was, he said, my committee name will be something like the name of the student. Now these names of students are in some order, okay? Name of the student and some marker. So Ach will be A, E, U, Rurlu, A, O, I, O. This is Ach, which contains all vowels. So he will call vowels Ach. And those in Andhra, they know that vowels are called Achulu in Telugu. Hmm? And the consonants are called Hallu. Now what is Hallu? Ha, Ya, Va, Ra. Let us ignore the ones which are in red color. Ha, Ya, Va, Ra, La, Nya, Ma, Na, 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 Ja, Bha, Ghadadha, Jabagadada, Jabagadada, Khapa, Chatata, Chatata, Kapa, Shashas, and Her, and then La. So Her to La, Her is repeated twice, but then Her to La, Hal, this is one set which is the consonant, and Ach is the vowel. So he devised this naming convention. If it is ik means Ivururlu, and here is K. So ik will be Ivururlu, H will be AOIO. So like this, he devised a method to name the sets. So now you know which elements are there in the set. Let me give another example. Here is khar. Kha, pha, cha, ta, tha, cha, ta, ta, ka, pa, sha, sha, sar. Ra is here. So khar will have all these elements in it. So like this, he devised a method to give the names of these sets, and then he used this in his Ashtadhyayi to refer to various subsets. Now there was a question, how did Panini arrive at this arrangement, this Shiva Sutras? Panini has not written any preface to his Ashtadhyayi. And then there are commentaries on these Ashtadhyayi. Nobody has tried to answer this question. So this is very a mystery, or it's a magical magic for us. How is that he arrived at it? And I would like you to take to Ramanujan. All of you are familiar with Ramanujan, who invented various important mathematical formulae. And when somebody asked Ramanujan to give the proof, he said, no, Devi Namakar came to my she came in my dream and she provided the solution. So he was contemplating on it and he got the solution. So when he says Devi provided the solution, actually he was totally immersed in it and he got the solution. But how he got the solution, how he arrived at the solution, that is not mentioned anywhere. So the proof which we all talk about nowadays is not given anywhere. Same is the case with Panini. And then there is a legend, just as in the case of Ramanujan, we have here also a legend. And they say that Panini was contemplating and then Shiva came, he played the Damaru and from the Damaru, several sounds emerged, and these emerged sounds are the Maheshwara Sutras, Yivun, etc. Well, but then there were several efforts in the 20th century to decide whether these partially ordered sets, from these partially ordered sets, whether it is possible to construct the linear arrangement as given in the Shiva Sutras. And they try to address this on various grounds. So Professor Cardona, who is from University of Pennsylvania, he gave some historical uh, reasons and tried to prove that yes, it was there in the earlier texts, etc., and Panini might have looked at them, and then on the basis of that he kept this order and so on. Professor Stahl, who was at Harvard University, he tried to look at the linguistic properties of the various columns and rows and how they are interchanged, etc., to get this order. Then there is Professor Kiparsky from University of Stanford, and he argued logically that if this set is subset of this set, then the elements of this set should be before the elements of the other set, and so on. And on that basis, he looked at all the these sets, 41 sets, subsets, and then he came up with the argument based on logic. But the best argument, best proof is given by one Professor Peterson. She is from Germany. She did her PhD recently in 2008-9 on in computer science, and her thesis was the proof, mathematical proof for the arrangement of Shiva Sutras and how these are useful, how this data structure is useful from computational point of view. So what she did was she had these partially ordered sets, and then she looked at the mathematical array. So she looked at it as a graph, and then she said that if this graph is planar, then we get this linear arrangement. And for the graph to be planar, there are certain graph oriented properties which she discussed and proved this result. And she also said that there are 12 million other such possibilities, and what Panini gave is one such possibility. She also proved that this is the innovative data structure, which is optimal one. Innovative because such a data structure never existed earlier, and we are also not familiar with such data structure. Even now, only from Panini we came to know about this data structure. Now, I'm not going to tell you why 12 million are possible. Here, some proof is given, but I will skip this. So, I want to go for the application point of view. So, what she actually did was she tried to seek answer to some general questions. Suppose I am given a set of sets like the one which I described. I am organizing some function, and then I have 41 subsets and 41 volunteers. Can I organize them as a linear list so that I just take slices and I get those various committee members' names? And if such an arrangement is possible, how to get one? Uh,
Good
and
morning.
is, yes, yes. And is such a linear arrangement unique? These are some of the questions which she tried to answer. I'm not going in the mathematical proof because it is highly mathematical and we need to know the graph theory, etc. So I'm skipping these things. And I will directly go to one of its applications. I don't have the slide, so let me explain. Now, what are the applications of such a data structure? Uh, all of us visit malls. Now, recently Diwali was there, so you must have visited mall. Now, in malls, they arrange various items in a specific order. And some of the times, same atom you will find at 2 or 3 different places. Uh, now, I am going to give an example from a simple, a normal mall where you have the grocery items. Now, let us take the oil. Now, oil, edible oils are there, and hair oil also is also there. Just a minute. Sorry. So, the oils, there will be 2 different areas in which you will find the oil. The edible oils are at one place and the hair oil is at different place. Now, let us take the example of coconut oil. Coconut oil is both edible as well as an hair oil. But then they process it in a different way and coconut edible oil will be with the edible elements and edible atoms, and coconut hair oil will be in another section. But this was simple because these two are 2 different atoms. But then let us take milk. Now, some people, they go to mall uh, and with milk they purchase vegetables, etc. There are few people who would like to purchase milk and bread together. So, on the one hand, you want milk and bread together. On the other hand, you want milk and vegetables together. Then with bread, somebody may would like to have the bakery items together. So this decides various subsets. And then there will be some overlapping between the subsets, that is the intersection is not empty. And in such cases, how we should arrange the atoms so that both the parties are satisfied. Let me give another example. Suppose we are organizing the books, classifying the books and organizing them in the library. Now, I will give an example of a book. Say the book is written on Ujjain. So there will be some historical element in it because historically it is an important city. Then tourist wise also it is important because there is this Kumbh Mela and many people would like to go and visit this place. And then there might be few other persons who will be interested in the Madhya Pradesh, and then the all the areas which are very close to Ujjain, etc. So and there might be few people who are interested in the religious aspect of Ujjain, okay, as a Dharma Kshetra and all that, because there is this Kumbh Mela and other things. So now the librarian has to decide, or let us forget about the librarian, let us go to any bookshop like Walden or any such, where the books are to be arranged. Now this book, the bookshop owner should keep at different places, in the religion section, in the tourist tourism section, and maybe in the historical section. So he has to repeat the copies of these, or if he has religion and history, first religion and then history, he may keep it on the border of these two so that both the people can see this. But then you cannot have three boundaries. If it is a linear arrangement, and typically the bookshops in the bookshelves are arranged linearly, so you need to have uh, you need to repeat the books. But then how to decide which atoms to be to repeat? So all these things Peterson has addressed in her uh, thesis, and here Panini had uh, repeated this her. You will see her here in the 14th line as well as in 5th line. So there is a repetition of her. Now, why it is only her which is repeated? Why not any other? Is this optimal solution? All these questions were answered by Peterson. She gave mathematical proof for all these things. I'm not going in details of those proofs. But then the answer to the question which was asked in the beginning about the Maheshwar Sutras, yes, this is a legend, and we didn't have any proof so far. But now with Peterson's work, we have a mathematical proof for it. Just as Ramanujan had given various solutions and proofs are being discovered now, same is the case with Panini's uh, Shiva Sutras as well. So it was an innovative data structure where instead of 1600 bytes, only 56 bytes were enough to represent these sutras, or the all the partially ordered sets. That was one part of it. Now I'm going to tell you something about one more property of this Ashtadhyayi. But before that, if you have any questions, please ask, and then I will move forward. Do you have any questions? Hello? Are there any questions?
சொல்லுங்க மேம்.
Yes. Yes. Is there any question? No? Shall I go ahead?
No ma'am.
Okay, fine. So I will go ahead.
Okay ma'am.
Okay. So the next one, I am going to talk about the compression. All of us are familiar with the distributivity in mathematics, right? A into B plus C is A into B plus A into C. Now, such a distributivity exists in languages also. Do you know? Let us take these examples. We say John goes home and eats fruits. Or we just say John goes home, eats fruits. We don't say John goes home and John eats fruits. We don't repeat John. Okay.
Okay.
So this is something like this distributivity. We have A at John, B is goes home, and C is eats fruits. This is same as John goes home and John eats fruits. So even in languages, we have this distributivity. And Panini used this distributivity for compressing his sutras. Now, when Panini was composing these sutras, he had, see, at that time, it was all oral transition of the knowledge. Okay. So they were not using pen and pencil and writing down the notes, etc. Everything was there in their brain. And when Panini was writing this or composing this grammar, what was the purpose of this grammar? The purpose of this grammar was to have an algorithm which is there in your mind, and when they were reciting Vedas, etc., then suppose some word form is to be derived, how to get this word form, then these sutras you can apply and derive the word form, or you can check whether the word form that is being recited is correct or not. So this grammar was something like a checkpoint for all the knowledge that was being transmitted. So this grammar, Panini wanted this grammar to be in the brain of a human being. Okay. Now, how many things you can remember at a time? Definitely, excuse me, there is some noise at the background. Okay, so what Panini wanted was, hello, what Panini wanted was a crisp grammar which is small in size, so that you can keep it in memory and use it as a program. So here I'm going to tell you, give you a glimpse of the sutras and how Panini achieved this compression, which is something very much similar to solving mathematical equations or simplifying mathematical equations. Here are these sutras. I have taken some 7 sutras, okay, from the first chapter, third part, second sutra, then third, fourth, fifth, sixth, seventh, and eighth. These sutras I have taken. Now, what I will do is, actually, when Panini wrote these sutras, in order to understand this, just as here, suppose you say just eats fruits, then you need to take this John also with it, and then the sentence becomes complete. John eats fruits. Okay. Similarly, here also, when Panini gave these sutras, Upadeshe Ach Anunasikit and then Hal Antyam. In order to understand Hal Antyam, you need 2 words, Upadeshe and It. I am not going to give the meaning of these at this point in time, but there are books which are called by the name Siddhanta Kaumudi, in which the author has given which words are to be repeated so that the sutra becomes complete in itself. So he said Upadeshe and here It, they need to be repeated. Then here in this it was only Na Vibhaktau Tusmaha, but Upadeshe, Hal, Antyam and It need to be repeated. Here Upadeshe and It are repeated. Here Adihi also repeated and Upadeshe and It are there. Here this Pratyayasya is repeated, Adihi also is there. And then here Adihi and Upadesha and It are there. So you see that words are repeated. So what I did is, suppose these sutras are given. I have marked them as, this is A, Upadesha let us call A, Ach Anunasik let us call B, It let us call C. So like this I have named them A, B, C, D, etc. Now I will remove all these Upadesha, etc., these words. So I have now mathematical expressions. One is ABC, then ADC, ADEC, AFGC, AFIHC, etc. And I have summation of all these. So suppose such an expression is given, we can simplify this further, right? And after simplification, what we get? Here we see that A is common, C is common, B, here DE, here F is common, then G and H, here curly bracket should have been there. In curly bracket, I plus J plus K. And this is what we get after simplification. And so it is like this, H and curly bracket IJK. Now if I write with indentation, A, B, C is here. I write D and E, then F, G, then H and I, J and K, one below. So wherever there is plus, I have added a new line. So something like a program in computer program, we have these indentations. So it is something like the scope of A and C goes till this. Scope of D goes up to this. Scope of F goes up to K. Scope of H goes up to K. So this is what is written here. And just I removed the indentation, and now I will replace ABC by those words which we had. So ABC, Upadeshe, Ach, Anunasik and It. Then this was your, Halantyam, D. Then E is Na Vibhaktau Tusma. Then you have F and G, that is Adi and Nitudavaha. Then H is Shaha, and then Pratyayasya, and then you have Chutu and Lashakvatadite. So these are different words, and this was the original sutra by Panini. This is the original one, which is same as Upadesha Chanunasiki Thalantyam Na Vibhakto Tusma. And here you will see Upadesha Chanunasiki Thalantyam Na Vibhakto Tusma, etc. So these two are exactly similar. But then there is no proper nesting here. See, here we should have the brackets, the open bracket is here and close bracket is here. You cannot have this close bracket before the curly bracket, or you cannot close the bracket here, because then there will be overlapping of the brackets. So they will not be properly nested. But in Panini's Ashtadhyayi, we find that here is Vruddhihi, which is needed in the third sutra. Here is Gunaha, which is needed in third sutra. But Vruddhi is not needed here. So such a jump is like a frog jump. Frog is called Manduka in Sanskrit. So such a jump is called Manduka Pluti. So such things are there in Panini's Ashtadhyayi. It's not that it's mathematically always we can have such nesting. Proper nesting is not there. But then if proper nesting is there, not there, then how can you understand the sutras, or how can you use it for mechanically getting the words from the previous sentences, etc., previous sutras, etc. So here there is some research done by Professor Bhate from Pune University Sanskrit Department, and she said that the major role in deciding this borrowing the words from previous sutras, this process is called anuvritti. And she said that in borrowing, you need to look at expectancy. If you need that, if you have some expectancy of the word, you borrow it. Otherwise, you don't borrow it. So, for example, if you have a sentence, John goes home, eats fruits. Now, eats fruits, who eats fruits? There is an expectancy. So you borrow that John from the previous sentence. But if you have John goes home and Mary studies. Now, Mary studies, here you do not need any any borrowing, because the sentence Mary studies itself is complete in itself. So there you don't borrow anything. So so essentially you need to see if there is any requirement, you borrow, otherwise you don't borrow. That's it. And then there were sutras like this. This is a very small sutra, Vanaha Vinayam cha. But then there was borrowing from as many as 12 previous sutras. So all these blue and red, these are borrowings. But then whatever is in brackets, parentheses, these are the words which are not needed to understand this sutra. So if you need it, you take it and understand. Otherwise, you just ignore those words. This is what Panini meant. Now, what is the advantage of this? Let us try to understand this. Total sutras, I said, are 4,000. In fact, there are 3,984. And how many words are there? Only 7,000 words are there. So some sutras have only one word, some have two words, some have three. But on an average, it is just approximately 2 words per sutra. So there are 7,000 total words. Suppose the words were repeated. So as we did here in this. So the original sutra has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Only 16 words. But here when the words are repeated, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 35. So instead of 16, now 35 words are there. So it is almost 2.1 or 2. Okay. So the number of words increase as you repeat the words, borrow the words from the previous sutras. So for these 7,000, if you borrow the words from previous sutras, the total number of words become 40,000. And now imagine, so what Panini did was, instead of 40,000, he reduced it to only 7,000. That means there was a compression of 1/6. And if we look at the byte size, there is a compression of 1/3. All of you might have used zip facility of computer, where you zip the files and the size is reduced. And do you know by how much amount the size is reduced? It is typically 2.7 or 2.8%, not 2. Its percentage is almost 1/3. Okay, so the size reduces by. So if the original size is say 287, it will reduce to 100. Okay, something like that. So the size almost reduces by 1/3, and Panini in those days could achieve this. Now, what is the advantage or importance of this reduction from the oral tradition point of view? See, students in those days, they were reciting this and memorizing this. Do you know how much time you need to memorize 7,000 words? You might have memorized few definitions. You might have memorized some poems in your school. Suppose such 7,000 words are to be memorized. 7,000 words means approximately 20 to 30 pages. Okay. And they are to be memorized in a linear order. You cannot change the order there. Okay. So I just went to one of these schools where such teaching goes on, and I asked the teacher how much time these students take to memorize this. They said, "Madam, they need 6 months." So 6 months are needed to memorize 7,000 words or 4,000 sutras. Now you imagine, instead of 7,000, if 40,000 words were there, the time required will be at least 6 times if the rate is linear. Okay, but the memorization actually needs exponential time. As the number of words increase, the time required is not linearly proportional, but it is exponential. And when it is exponential, definitely it's not just 6 times, but much more. Now, instead of 6 months, 6 times of 6 months means 3 years. Now, imagine if a student is just memorizing something, goes to school, and what he is doing, he is memorizing. 3 years happen, go 4 years are gone, and still he is memorizing. What will his parents think, or what will he be? He must be feeling bored. Oh, what is this? I'm just memorizing. I'm not learning anything. So it was very essential at that point in time for Panini to compress this, and the method of compression was this anuvritti, or a factorization, or the rule of distributivity which we use in mathematics. So with this, now I stop. There are many other properties of Panini's grammar, computational properties of Panini's grammar, which I have not touched, but only two properties I have highlighted today. One is an important data structure, which is the Maheshwara Sutra, and the second one is the compression technique. So if you have any questions, please feel free to ask me the questions.
Thank you so much, Professor Amba Kulkarni ji. Of course, it was a very enriching session. Now I'll request the students in case they would like to know something.
Sure.
Shreya, beta, you have the mic. Ayush, you have the mic.
What?
Would you like to know something?
Ma'am, I don't know Sanskrit.
Okay. Then,
There is a question from YouTube.
yes.
Whenever there
Please go ahead, Meenu Didi.
Ji, Didi. So Rajasekaran is asking, ma'am, ma'am, are you linking language to computer data structures, or are you linking data structures to the language?
Well, the question is, are you linking data structures to language, or
language to the data structures?
No, the first one was,
ma'am, are you linking language to computer data structures, or data structures to the language?
Okay. Okay, fine. Now here I'm not doing either of these. It's not the language, but what I'm doing is explaining how the grammar is written. So this grammar is something like a program, and when you are writing a program, you need data also. So a program, there is a very good book. I remember this title of a book. This book is on Pascal, and Nicholas Wirth, who discovered this Pascal for teaching programming languages, he wrote the book whose title was Algorithms plus Data Structure is equal to Programs. So a program is a combination. Program is not just an algorithm together with a data structure. So today what I wanted to highlight was Panini wrote grammar in the form of a program. Now if it is a program, then there should be algorithm and there should be some data. So what is the algorithm? The sutras themselves are the algorithms, and the data structure is which is something which is outside these algorithms. So Maheshwar Sutras is one kind of data structure, and there were various other data sets. For example, he used lists called Dhatu Patha or Gana Patha, etc. So there were some ancillary data sets that were there. So you have the data and you have the algorithm and you get a program. So I am not relating language with data structures or data structures with language. No, what I am trying to highlight is Panini's program, Panini's Ashtadhyayi, Panini's grammar is like a program, and therefore I am calling him the foremost programmer. The algorithm which he has given or the data structures which he has used, those I have highlighted. Does this answer your question?
I think it does, ma'am. Thank you so much. There is one more question from many participants like Dikshita. They want to know the importance why you have used red color to highlight certain letters.
Oh, okay. So let me go back to my slides. Yes. So the red color was actually the marker which Panini added. And what is the importance of that red color markers? These are something like, suppose you have a garland. In garland, you have different types of flowers, and in between there are these knots. What these knots tell you? They tell you what is the boundary. So it is something like a boundary of a set. So even so this says that this is one set. Okay, rirlik, this is another set, but you can have one more set with aivu and rirli, because there is again here marker, and you can ignore this marker and form another set like this. So these color here in Shiva Sutras indicate this is the marker. And in the case of Anuvrutti, the colors, they pair to tell you that these are words from different sutras. So these are different sutras which will be repeated in the following sutras. So I use different colors here. Is this okay?
Very beautiful explanation, ma'am. Thank you so much.
Thank you.
Didi, please take over.
Yes, yes, very nice, ma'am. Maybe some of the hands which are risen, I'll pass on the mic. Srihari. Srihari, beta, you have the mic.
Yes, ma'am, I have a question.
Yes,
Yes,
please go ahead.
Mr. Ma'am, usually grammar is considered to be a not like subject as other languages, right? So do you think that the teaching grammar in the way that Panini once understood and he taught would invoke curiosity in studying grammar?
Okay. See, grammar actually is like a science. Okay. It is science of language. Hmm? So, how a language works? How is that we are able to communicate our thoughts to other person through the language? So, what are the constraints on making a language string? So, the grammar actually tells you about this process of communication. Okay, how not process of communication, how to encode the information, how to encode your thoughts in a language string. Okay, so it is something like a science. See, I will compare it with mathematics. I am a mathematics student, so I like comparing it with mathematics. Now the calculations, addition, subtractions, etc., all of us do. But then in school, we are also taught something more about the properties of numbers. Okay. Uh, then properties of various operations, that when you add 0 to a number, it remains same. When you multiply with 1, it remains same, and so on. See, those who have not studied mathematics, it's not that they cannot do their addition, subtraction, multiplication, etc. They can do. But what we learn in schools is something which helps us in trying to generalize, trying to understand it in a better way, and so on. So, uh, it's the science behind mathematics we teach to students, how even geometry, etc. Similarly, the grammar is something which helps us in understanding the language in a better way. If I know grammar of one language, and Panini's grammar, it is claimed, and people even now believe and try to uh, even use it to uh, describe the grammar of other languages. So Panini's grammar is something universal grammar. So now what is the use of this universal grammar? If Panini's grammar is universal, and if Panini's grammar is computational, then we can we can develop various computational tools to do the language processing, that is the natural language processing. And if we can have such a grammar, if we learn such grammar, we will be in a better position to develop better systems for computers, right? So it's not that if you know grammar you can speak language in a better way, no. But if you know grammar, you can do several things in a better way, especially in today's language technology era, where natural language processing is taking leads. You see so many translation systems are there. Google now can translate from one language to another, or if you write in one language, you can read the message in another language at another end. Or there are even programs which are being developed where you speak in one language, the other person listens to it in another language. With virtual reality, the same person can be there, and then that person will be speaking in another language and all that. So all these are possible because of the technology, today's technology. And for that, the science that we need for the development of this technology is there in India. The Panini's grammar and various other systems of language communications that were developed over a period of time. All these are there, and they have the potential now for their use. Now we have this technology available, so there is a possibility that we can use them for betterment of ourselves.
Thank
Does
you.
this
Thank you.
answer? Okay.